Hello, Honors Pre-Calculus. Welcome to our last week of new material. So last week we talked about parametric equations. This week, both Ms. Cronky and I are going to talk to you about what's called polar coordinates. So in today's lesson, we're going to talk about what polar coordinates are and how to switch back and forth between the XY coordinates that we know and the polar coordinates that I'm going to teach you about. And then the next lesson, Ms. Cronky is going to go through how we go from equation to equation, equations with XY that we're used to, and then equations that are in polar form once you get a handle of how to do the coordinates. Okay, so this week you have the two videos with our worksheet, and next week will be our last week of academics, where you will do a review and assessment over parametric and polar. Okay, so let's go ahead and get started. Okay, so polar coordinates actually have nothing to do with polar bears, but this is always how I like to start out this lesson. Polar coordinates actually have to do with rotational angles and direct a distance from what we call the pole. So that polar bear is sitting in the middle of the XY plane, okay? In polar coordinates, the origin is actually called the pole, okay? Which is actually why it's called polar coordinates. So let's talk about the differences between what we call rectangular coordinates and polar coordinates, okay? So in rectangular coordinates, we like to move horizontally in terms of our x variable, okay, and vertically in terms of our y variable. So that's just shorthand for horizontal distance and vertical distance. Let's say I'm going to plot the coordinate 2, 2. Okay, I am first going to move to horizontally 2, and then I would move vertically 2 so that I could plot my point at 2, 2. Okay, now we don't actually show the move right, move up when we plot our points, but mentally that's what we think about. Okay, now for polar coordinates, okay, notice how I have instead of a rectangular grid, okay, that's why we call these rectangular coordinates. We move rectangularly right, left, up, down. Okay, so instead of our rectangular grid, I actually have more of a circular grid. Okay, so polar coordinates, like I mentioned earlier, they're called polar coordinates because the origin is now what we call the pole. Okay, and instead of having our XY coordinate like we do in rectangular, we have a coordinate r comma theta. Okay, r is actually going to give us a directed distance from the pole, okay, which means if we have a positive r, we're going to move forward from the pole. If we have a negative r value, we're going to move backwards from the pole. Okay, and then theta is what we would consider like our directed angle, you know what I'm going to call it instead, our angle of rotation. Okay. So back in chapter 4, we worked with angles of rotation. So starting from the positive x-axis, we would rotate, okay? That's what theta is going to represent, all right? Before I show you how to plot a coordinate, I do want you to think about this. The x, y coordinate, those variables are in alphabetical order, x, comma, y. R, comma, theta is also in alphabetical order, R, and then theta starts with a T. Okay, so if that helps you remember which one comes first. I'm actually, when I plot these coordinates, I sort of like to think about it backwards. So let's say I wanted to plot the coordinate 4, comma, pi over 3, let's say, okay? I like to first think about the angle. So if we rotate from the positive x-axis, we know that this guy right here is pi over 3. So what I'm going to do is from the pole, which is here, right? Here's the pole. I'm going to move along that angle a positive 4. 1, 2, 3, 4. And that would be our coordinate. Okay. Now, let's go ahead and change our coordinate. I'm going to write in green now. If I had the coordinate negative 3 pi over 3, okay, I'm still talking about using this same angle, okay? But since we have an R value that's negative, we would actually move along that line, but we would move backwards 3. Okay, so remember this was our pi over 3 angle, but from the pole, we had to move in reverse because of that negative 3. Okay, R is a directed distance. Okay, so we'll work with polar coordinates throughout this whole thing, but we'll work with that concept a little bit more as we go through. Okay. So let's go ahead and come to here first. If you are trying to plot something like this at home, okay, so if you don't have the ability to like print out your worksheet, or right now in your notes, you don't have something that looks like this, what it is we have the XY axis, right? And then we have the pi over 6 butterflies, the pi over 4 butterflies, and then the pi over 3 butterflies, with concentric circles, so circles that all have the same center, and those circles are kind of our grid marks for R, okay? So what we're gonna do is we're gonna plot the coordinate 3, negative 3 pi over 4. And like I just mentioned, I really like for you to think about rotating that angle and then moving along the edge of the angle. So if we are going to consider negative 3 pi over 4, we know that we're going to have to rotate backwards, okay, in reverse. And 3 pi over 4, if we go in the positive direction, would land us right here in the second quadrant, okay? So if we go that distance in reverse, we're looking at this angle right here, okay? So there's our negative 3 pi over 4. But then I would like to move out along, and maybe I should keep that highlighted. I'd like to move out along that angle a positive 3. So here's 1, 2, 3. Here's that coordinate. Okay. Now there's actually an infinite number of ways we could describe this coordinate in polar form. Okay, and this is something I'm going to ask you to do both in your homework this week and then next week on our review and assessment. But what I would like you to do is make sure you're staying between negative 2 pi and positive 2 pi. Okay, so what we can do is let's go ahead and write this coordinate where we have a positive angle. So if we were to rotate normally in the positive manner, we would call this angle 5 pi over 4. So this coordinate is also 3 5 pi over 4. Now, we could also think about our R value being negative. So if we were to rotate to this angle right here, we would have to move backwards along that angle in order to get to that pink coordinate that I have. And so if we rotate to pi over 4, we would have to go in reverse 3 units to get to that pink coordinate. So negative 3 comma pi over 4 would be another way that we could describe that coordinate right there. Okay. And then finally, if we think about rotating to the same yellow angle, but in the negative direction, okay, then we could also describe this coordinate as negative 3, negative 7 pi over 4. We could get to that yellow angle by rotating to negative 7 pi over 4 and then moving backwards along that angle. Okay, so for each coordinate, there's going to be a total of 1, 2, 3, 4 ways to describe that coordinate, as long as we stay in between negative 2 pi and positive 2 pi for our angles. Okay, maybe you're thinking of the question, do we have to use radians? And the answer is yes, I really would like you to stay in radians. And I think at this point in honors pre-calculus, it's probably easier to stay in radians because we've used them so often. Okay, now let's go ahead and come back to the concept of both rectangular and polar. Okay, I want to be able to take a coordinate like this 2, 2, and be able to write it in polar form, or vice versa. Maybe we want to take this coordinate 4 pi over 3 and write it in rectangular form. How do we convert from one to the other? Okay, you'll notice as we go through this, there are going to be coordinates that are a lot easier to describe or maybe to plot in one form or the other. So it's nice to have the option of 2 different types of coordinates to be able to work in. The same is also going to go for like equations and graphs. We don't really get into the really cool graphs that we can do with polar coordinates, but with equations, with graphs, there are things that are a lot easier to work with in rectangular form, but then there's also some graphs and equations that are a lot easier to work with in polar form. Okay, so we need to be able to go back and forth between the two. So I'm going to draw an XY axis here. Okay. And we're going to call this coordinate X comma Y. Okay. But we also could call this coordinate R comma theta. Okay, so let's talk about how we would get to that coordinate in both of these forms. So if we were going to plot this rectangularly, we would, oh, that was not a good line. We would go horizontally X, and then we would move vertically Y. And since this is rectangular motion here that we're using, that would make a right angle. Okay, well now let's consider what we would do in order to plot this if it was in polar form. In polar form, we just talked about how we would rotate a certain angle theta and then move forward r. And I hope that you're smiling because you look at this triangle and maybe it looks familiar to you. Okay, if we flash back maybe to chapter 6 a little bit, there are some things that look awfully familiar here. Okay, and that's a good thing. So let's talk about the most obvious. We have a right triangle. We know that x squared plus y squared equals r squared because we have a right triangle, and that's the Pythagorean theorem. Okay. We also know that the tangent of theta equals opposite over adjacent, so y over x. Okay. These two equations are often grouped together and are very helpful when you know x and y, and they allow you to find r and theta. So if you know x and y, you can solve for r in this equation. If you know x and y, you can solve for tangent in this equation. Okay. Don't write this down right away, okay? Just watch me do this one little part. I'm gonna go back to this tangent, okay? Well, there's lots of trig functions we can write. Well, not lots, really 6, okay? But 3 ones that we really like to focus on. So let's talk about the other 2. We know that the cosine of theta is going to be adjacent over hypotenuse. And we know that the sine of theta is going to be opposite over hypotenuse. Okay, now if I were to rearrange both of these, okay, and this is what you'll want to write down, right? If I were to rearrange both of these and I want to solve each of these for x and y, then I would multiply r to the other side to where x is r cosine theta and y would equal r sine theta, okay? And these two we often pair together. And these two conversion equations help us when we know r and theta, we can plug them in and solve for x. When we know r and theta, we can plug them in and solve for y, okay? So I'm gonna highlight in orange 1, 2, 3, 4 conversion equations that you want to be able to find and use. You will use 1 or 2 of these in any conversion problem that I give you, okay? So let's go ahead and try that, okay? We are going to convert from rectangular to polar and polar to rectangular, and then that will be the end of today's lesson because we're just focusing on coordinates in this video. And then Miss Cronky's video that you'll watch next will focus on equations. Okay, so right now we're just focusing on coordinates. Okay, so this is a rectangular coordinate. So we know that this is x, comma, y. All right, and just for a visual, I'm gonna go ahead and plot it. 1, -1 is right here in the 4th quadrant. Okay, now I just mentioned if we know x and y, then these top 2 conversion equations make it really nice for us to solve for r and theta. Okay, so we know that x squared plus y squared equals r squared. So 1 squared plus -1 squared equals r squared. Okay. So r squared is 2, and yes, technically when we square root both sides, we would get the r as plus or minus radical 2. But since we're going to write the coordinate, I really want you to focus on one or the other. And it's going to be easier if we just focus on the positive one because then we're moving forward along that angle. okay? So I'm going to choose r is a positive radical 2. Our other conversion equation is that the tangent of theta is y over x. So in this case, the tangent of theta is negative 1 over 1. Okay. So I need to know where the tangent is negative 1. Ladies and gentlemen, I don't need you to be using your calculators, okay? Especially since we're in radians, it's not going to give you a pretty number anyway. You're not going to know what it means, okay? I want you to use your unit circle knowledge, okay? Back in Unit 4, both Ms. Cronky and I said, hey, you're going to use the unit circle for the rest of the semester. And here it is again, okay? The tangent is equal to negative 1 actually in 2 different places. Okay, we know that the tangent is equal to negative 1 at both 3 pi over 4 and 7 pi over 4. Okay, well, how do we know which one to pick? Okay, good thing we have a picture. I went ahead and I plotted our point over in this corner. Okay, it looks like our coordinate is in quadrant 4. So it would make sense for us to choose 7 pi over 4 as our angle because it matches where our coordinate is placed. So our polar coordinate would be radical 2, comma, 7 pi over 4. Okay. Our last question is, or our last example, I guess I should say, we are going to convert the coordinate radical 3 pi over 6, and I guess I didn't finish typing this out for you, and I'm sorry. We're going to go, this is a polar, and we're going to go to rectangular. Okay, so I gave you a polar coordinate, give you polar coordinate that we are going to convert into rectangular. So radical 3 comma pi over 6 means we would rotate to this pi over 6 angle and we would go out radical 3. Okay, now radical 3 isn't the most accurate distance to measure along the angle. So if you have those concentric circles, just approximate. Radical 3 is almost 2, but not quite, okay? So now when we convert from polar to rectangular, we can use those other equations to do the conversions. And actually, this is a lot easier. You don't have to think about the quadrant. All you have to do is plug in r and theta, and the trig does the work for you. Okay, so very similar to our vector unit, x equals r cosine theta. So we can plug in r and the cosine of pi over 6. Okay, well, ladies and gentlemen, what is the cosine of pi over 6? I hope you said radical 3 over 2. So radical 3 times radical 3 over 2 would give us 3/2. Okay, then for y, very similar to our vector unit, y is r sine theta. So we have radical 3 sine of pi over 6. And we know that the sine of pi over 6 is 1/2. So our y coordinate is radical 3 over 2. So in rectangular form, our coordinate is 3/2, comma, radical 3 over 2. Okay. So that brings us to the end of our lesson. You have an assignment, and this assignment is going to include problems like I went over and problems that Ms. Cronky is going to go over. So if you're going to work on your assignment right now, make sure you focus on everything that is coordinates. Okay, and once you watch Miss Cronky's lesson, you can focus on the ones that are equations. Okay, so this is the last video that I will make for our school year. Okay, you have one to watch from Miss Cronky, and then next week our reviews and the assessment. So thank you for joining me. It's been a lovely way to end our semester. If you haven't come to a Zoom session, I would encourage you to hop on to mine if you're in my class, or Miss Cronky's if you're in her class, and at least say hello, ask a question. But we do miss you. We miss you lots and lots. This isn't how we envisioned we would end our semester, but this is what it is, and we're making the best of it. So thank you for all of your hard work, and we will see you again soon.